Okay, everybody. Today we're going to talk about figuring out in a more complex way the total number of possibilities we can have to do these problems, and that starts with the fundamental counting principle. The fundamental counting principle states that if we have m options for the first choice and n options for a second choice, then the total possible options combined is m times n. And if you have more than two, then you multiply more than twice. So, for example, if you think back to kindergarten, you had 4 different shapes to choose from, and you could color them in 3 different colors. 4 times 3 is 12. So there was 12 possible outcomes that you could create. Now, the next thing, all right, in this unit that you need to be able to do is permutations and combinations. Okay, permutations are a situation where order matters. Combinations are where order doesn't matter. That's the major difference. All right, so you got to make sure you read through that when you do word problems. So, for example, let's say there's 35 students on a school student council, okay? And you are choosing out of those 35 students a president and a vice president. Since those 2 jobs are different, okay, they're considered separate. So we can go back and use the fundamental counting principle. We have 35 choices for president, and assuming then that not the same person can be president and vice president, we would have 34 different choices. It goes down 1 each time. You would then do 35 times 34, which is 1190. If you use the permutation formula outlined in your notes, that would be 35p2, which converts over 35 factorial over 35 minus 2, which is 33 factorial, which brings you back to 35 and 34. But if you were picking 4 people for a dance committee, all right, now all 4 people on the committee, they're doing the same job. So now order doesn't matter. So that's when you do combinations. The number of people we choose from is the first number, the 35, and then the capital letter C. And then the number of people that are going to be in the committee, in this case, would be 4. And then that would convert into n factorial over r factorial and minus r factorial. So 35 factorial goes on the top. We're choosing 4 people, so that's 4 factorial. Then 35 minus 4 is 31 factorial. Okay? Now, basically realize those 2 numbers always add up to that one. That one's the first number, and that one's the second number. Now, when you're doing this, okay, if you're using a graphing calculator, you would hit the math button. You would then choose the PRB menu, and you would choose the number 4. Okay, if you don't have a graphing calculator, we're going to talk about factorials in a second, you're going to realize a lot of things cancels out, which is what you're going to want to do. All right, and speaking of factorials, if you either don't remember it or have never seen it before, n factorial is n times n minus 1 times n minus 2 times times all the way down to 1. All right, so if we were starting with 5 factorial, all right, it'd be 5 times 4 times 3 times 2, which ends up being 120. Now, the numbers get big. Even if you're using a graphing calculator, the numbers get big. So, for example, if I do 22 factorial, 22, and I hit math, I go over to well, let's start that again. So if I'm going to do 22 factorial, all right, it's 22, and then the math button, and then I slide over to PRB, which is the one all the way to the right, and you'll see next to number 4 is the factorial button. And I hit enter. And you see you get a number in scientific notation. These numbers get really big really quick. So my suggestion to you is you look for things that cancel out. So for example, if you were doing 22 factorial over 19 factorial, 22 times 21 times 20 over 19 times 18 times 17. Well, hopefully you recognize everything after 19 cancels out. So you end up only doing 22 times 21 times 20. All right, again, the numbers get big really, really quick. So basically, when you're doing this with permutations, since this is the basic formula, you're going to start with the number as the numerator, keep going down 1 until you get 1 more than the denominator. If this was 15 instead of 19, you would go down to 16. That would be my suggestion in doing these. All right, now let's do some problems. So in the attached handout, the standardized test prep, all right, the first problem, these were graded response questions. It says Solve each exercise and enter your answer on the grid provided. And how many different ways can 6 books be arranged on a bookshelf? All right. Order matters because where it is, the first book, second book. So whenever it's an arrangement problem, just assume order matters. So it's just going to be 6 factorial. So it's 6 choices for the first one, 5 for the second one, 4 for the third one, all the way down until you get to 1. When you multiply all those together, you get 720. All right, so if you're just doing arrangements, you just do the total number of items, factorial, and then you multiply all the way down. Second one, number 2, the option for college's science classes are shown in the table. You have title, Science 101, 105, so you have 2 different science courses. Grade types, you have pass, fail, letter grade, so there's 2 different ways it can be graded. And times, 9 a.m. to 10:30 a.m. All right, obviously most of us pick the 10:30 a.m. class, especially when we're in college, but that's for a later day. All right, so when we're looking at the title, you would have 2 for the first, 2 for the type of grade, and 2 for the times. So there's 2 choices, times 2 choices, times 2 choices, which is 8, which means you have 8 different choices, assuming they're all the same thing. That's how many combinations of class type and times are available. All right. Now, number 3, how many combinations of 4 fish can you choose from a tank containing 8 fish? Now, when we're putting fish in a fish tank, it's not going to matter which one we pick first. They're all just going to swim around. So this is a combination problem. So I use NCR. There's 8 fish to choose from. So that's the lead number, and there's 4 fish that we're choosing. So it's 8 factorial. 8 factorial over 4 factorial, which comes from that, and then 4 factorial, which comes from 8 minus 4. 8 factorial is 40,320. 4 factorial is 24. 4 factorial is 24. So you just basically do 40,320 divided by 24 squared, and you end up with 70. Okay, now all right, number 4, which is the most complicated problem on there. It says a bag contains 7 marbles, 1 each of red, orange, yellow, green, blue, violet, and white. Child randomly pulls 4 marbles from the bag. What is the probability that the marbles chosen are green, blue, red, and yellow? Round your answer to the nearest hundredths place. All right, so basically they tell us the number of marbles, which is 7. All right, and we're choosing 4 marbles. Randomly, a child is pulling from the bag. What is the probability the marbles chosen are green, blue, red, and yellow? They're not saying that green's chosen first, so green can be picked at any point. All the colors, so it's a combination problem. So it's 7. This is how we're going to get the total number of possibilities. This is our denominator. So 7 choose 4 is 7 factorial over 4 factorial, and 3 factorial, because 7 minus 4 is 3. 7 factorial is 5,040. 4 factorial is 24. 3 factorial is 6. So we're basically going to do 5,040 divided by 144, and we get 35. That's the number that's eventually going to end up in our denominator. To get the numerator, you're simply going to use the fundamental counting principle. All right? So how many choices do we have that are good for the first one? 4. All right? We're going to go through another one of these problems in a second. 3 times 2 times 1, and we get 24. All right? So there's 24 possible abilities that we get those 4 colors. When I do probability, I get 24 over 35, which simplifies down to 0.68. Now, they said to round the nearest hundredths, so the answer for that would be 0.69. Now, the last one. All right. Number 5. Number 5, their teacher wants to choose 1 student to take attendance, 1 to hand out papers, and 1 to collect homework. So there's 16 students total. So to hand out papers, there's 16 different students to choose from. All right. Then there's going to be 15. All right. Then there's going to be 14 for the third. It always goes down. The order matters because the jobs are different. All right. 16 times 15 times 14 is 3,360. If we were going to use a formula, since the jobs are different, we would use permutations. So it'd be 16, choose 3, would be 16 factorial over 13 factorial. Because 16 minus 3 is 13 factorial. We end up with 16 times 15 times 14. And our final answer is, either way, 3,360. All right. There you go. Tomorrow we'll talk about compound probability. All right. And then on Wednesday we will talk about conditional probability in a couple of ways with both models and a formula. And then all the work that is due on Thursday. If you don't get it done by Thursday, then you got to do it over Memorial Day weekend, Friday, Saturday, Sunday, Monday. All right. But as long as you get it in by Monday, all right, everything's good. Tuesday, we'll post the quiz. You have 48 hours to do that through Wednesday. And then that'll cover it for the probability unit. Have a great day.